Okay, so it's a matrix problem. This problem is from hot 100, LeetCode hot 100. Okay, so set matrix zeros given and multiply an integer matrix. If an element is 0, set its entire row and column to 0. Okay, and it must implement in place. Okay, so the first question is, how many zeros will there be in this matrix? Oh, so it seems like there's no limit. Okay, so for the matrix, the first idea that I came up is to so we will walk through every element in the matrix and see if it's 0. If it's 0, then we will mark its column and row to 0, and then we will return and move on to the next element in the matrix. But okay, there are some special cases, like if we we have to maintain another matrix to keep track which element we have already visited, and if it is already visited, then the next time we have encountered, then we will not get into it. But we have to set, sometimes we have to set the already visited element to 0. Okay, the thing that I am thinking is that if we have we have replaced the element, the value to 0 already, should we visit it again, or I think we should not visit it again, because then we will cover all grid to 0. So, but when we first see a 0 in a grid, and we check its neighbor, if it's 0 as well, then we will also have to cover. and things get complicated now. Okay, so we will first make, I think, to maintain a visited grid is definitely that we have to implement one. So and we will loop through each element in the matrix, each value in matrix. If it is not visited yet and its value is 0, then we will start coloring its neighbor. Color its row and column to 0. And also yeah, the problem is when we are coloring, and if we make a value that is 0, we should also color it its row and column, but I want to separate it so that the for loop inside will only focus on what it has to do. Okay, so maybe we only covered I think maybe we will make the 0 to some kind of symbol that is not integer. Yeah, maybe like or any yeah, and I think, okay, so I think maybe when we, yeah, so when we gather it's row and column to 0 if the current value of the so if the square that we want to cover is already 0, then we will stop and then return, and yeah, we will not set it to visited. So since we cover, we will set the square to visited, and we will not get into it again. And if we met a 0, that is already 0 in the square, so we will not cover it. Instead, we will stop the process and then yeah. Okay, so when covering, we will start coloring color color in 4 directions, and if we meet a 0 that is not visited, return. And else we will set the coloring square to visited, and set to 0. So I will first use a depth first search, since it goes like for one direction, it goes to the depth, the boundaries, and oh yeah, if also for the boundaries. So I and j is the index of the matrix. if I is smaller than 0, or j is smaller than 0, or I is larger or equal to, okay, let's set n is the length of matrix. Let's have m. N is the length of matrix 0, first row. Okay, so if I is larger or equal to m, or j is larger equal to n, then we will return. Else, then we will set. Okay, we will have visited matrix that is false at the start. So yeah, it will have like this, and it will have like n rows. So we will set visited ij to true. Oh, not that. Oh, yeah, I'm thinking of it. Can we do a recursive, like if we met another 0, then we will also have color its row and column until we met the boundaries and no way to go. Yeah, so we will first set the matrix ij at visited to true, and then we will start coloring. Okay, so that's color. Okay, I think no, we will have to do it like if we met any 0, then we will stop. And the rest of them we will set it to true, and we will start coloring think we have to have a parameter for direction. So if direction is left, then we will do we'll set ourselves to 0. And start coloring in the direction. So we'll have recursive, and for left it will be J minus 1. And if direction is right, then it will have DAFS J plus 1. Up, then we'll have I minus 1 and J. If direction is equal to down, then we will have DFS I plus 1 J. Yeah, so they will recursive doing the coloring to 0 until it met the boundaries. So then we will look through the matrix to check if there's zeros. So for I in range M, let's say for row, for I in range M, and for J in range N. If matrix I J is equal to 0 and it's not visited, then we will do the DFS I think we will have IJ and then left. Yeah, we will have like IJ left. So when it enters, it will set itself to 0. Yeah, it's it is not a problem. Oh, but it is equal to 0. Okay, so maybe we will have like that. We'll do the same thing like this. Oh. Yeah, we'll have the 4 directions. I think we can do some optimization here, because it's kind of repeating the same thing. Yeah. But well, we will first see if this is the answer. We'll see if this is in the right direction. Yeah, so okay. So when we find a 0 and it is not visited, we will go through the 4 directions. And okay, so for example, the left one, it will go inside the DFS function and first replace it to a 0, and of course set the visited matrix to true. And so its direction is left, so it will go on to the right, left again, and it will not to the right. Yeah, so it will only cover its row and column. Yeah, so then after this operation, I think we will get a modified matrix. Yeah, let's see if this is correct. No. Yeah, but it's like OMN space. Oh. Okay, there is something wrong. Let's see what happens. So it is 1, 2, 3, 4, 5, 6, 5, 0, 7, 8, 0, 10, 11, 12, 13, 14, 15, 0. Okay, so let's see why we are outputting an error answer. So for this 0, okay, so for the first oh, I see. If the matrix is equal to 0 but it is not visited, then we will return. But if it's visited, then it is not a big deal. So we'll have it like this, and visited ij is false. Okay, quite well. So, oh, okay, so pretty nice. At least we have passed the test. Okay, so let's see where we can optimize. Okay, so the follow-up says that we should not use OMN space. We should use like an OMN n plus n space, or maybe like a constant space solution. So I think the bottleneck is the visited metrics. So I am thinking of if we can or if we know the current, like we know which zero we are coloring for, that like the center of the coloring of the coloring task, then we will not have to know the visited, because so this metric, the square, like the numbers that is equal to 0 and not visited, it will always be after the center, the coloring center 0. So yeah, if we put so if we have add the parameters like ci is the center of the coloring thing, then we will not we don't need the visited thing. Is it correct? Yeah, but we'll kind of yeah, I'm thinking if we like this, we color this for first, and then when we loop through here, or we know where to yeah, we should not cover these. We should skip and then to here. Okay, so maybe we will no. Yeah, if we idea to start it here? How can we know we should start here? Yeah, we can. It's hard. Yeah. The bottleneck is that we cannot separate which zero is already colored and which zero is colored by other central zeros, or it is a zero that we have to color its neighbors. Or if I'm thinking of putting some symbols like tag these central zeros to maybe a maximum int, then things may be easier, because whenever we see a maximum int, then we will start coloring its neighboring zeros, and we don't have to care about the zeros. We will just have to care about the maximum int. That may be a plausible solution. Yeah, and when we look through the grid, whenever we match zeros, then we will not care about it. We will only see if any value that is not zero. But we will only try to find the next infinity. Yeah, that sounds quite good. So when we color, just like this, when we color the zeros here, if we see a maximum int, then we will return. And okay, so we will return and start it here, right? No, we will return and start it here. And if it's a zero, then we will skip. A zero skip. Is a maximum int, then we will start coloring. If it's a zero, then skip, then we will color these. And if we finally finish, then we will start it here. It's a zero, okay, skip. It's not a zero, not. Oh, so we don't care. Yeah, if it's not infinite, if it's not a maximum int, then skip. Then finally have the answer. Yeah, I think maybe it's working. Okay, so I will have like solution to like optimize. I will first replace the zeros to inf, and we will still loop through each value in the grid. And if if we see if it's an inf, return. Loop through each value in the matrix. If it's an inf, then we will start coloring its row and column to 0. When coloring, if we meet an inf, return. So that's first, we'll remove the visited array, and then we will first loop through the matrix. If matrix is equal to 0, then we will change it to inf. Okay, then we will start our looping. If matrix equals inf, and in the end, in the end, we'll have to replace the inf to 0. Yeah, kind of like this. I think we don't need to modify the rest of the code. Since it's inf, then we will do the coloring in the 4 directions, and if you're left, you have to keep coloring the left direction. Yeah. So the first thing, you have to color yourself to 0. Yeah, and then check which direction are you coloring. Are you command to color. So yeah, you have to keep color the direction that you are coloring. Okay, so at this, then you will finish the task. If you finish the task, yeah, if you kind of like meet the boundaries, then you will return, and if you meet another infinity, you will return as well. Then we will get to here. Then yeah, we will move on to the next number, and check if it's an infinity. If not, then we will continue. Okay, so when we finish, we will have to color the infs back to 0. Let's see if it's working. Yeah, then we will use constant space. But it's kind of slow. I'm using constant space. I'm not sure why it is so slow, and maybe let's see the solution. Okay, so it seems like the solution is not my thoughts. It's another kind of thought process. So okay, so I think I will read it, and then we will oh yeah, it is like keep track of each row or each column. Does it have 0? And if that row and if your column has 0 or if your row has 0, then cover yourself, replace yourself to 0. kind of what is the size of inch? Okay, so the solution, the official solution will be keep track of the zero in each line, each row and column. So okay, so the first thing is that if they use they will use like two arrays to keep track whether this row has a zero or this column has zero. If yes, then color itself color itself to zero, replace itself to zero. And how can we optimize this space to like O1 space? It says to it wants to use the matrix, the first row and first column of matrix to keep track of the zeros. But yeah, there is many there will be many things to notice, because then you will cover the original data. Okay, so yeah, they have the solution that to address the problem, that if we put the zero records in the first row and first column of matrix, they use like two constants to keep track that whether the first row and the first column contains zero, and it will, if yes, then at the end of the calculation, the coloring, they will cover the first row or first column. Yeah, it's still pretty straightforward. Okay, so let's rewrite to the optimal solution. The official solution will be first keep track of which row and which column contains 0. And while looping through the matrix, replace the value to 0 if the record said that the current row or current column is 0. Okay, so we will first for loop. The metric for loop our matrix, and if matrix ij is 0, then we will have the matrix we'll have the first row of the matrix to be 0, and also its column will be 0 as well. Let's start from 1, so we will not okay, that's and then we know the information of each row, like which row has 0, which column has 0, and now we will loop through the matrix again and color all of it with zeros. And the reason why I started from 1 is because we keep track of the information in the first row, and I don't want to make dirty of the data. So we will first start from the second row and second column, and at the end of the coloring, the replacing, we will go back to the first row and see if we need to if we need to replace the first row to zeros or the column to zeros. Oh, but this, yeah, we have replaced the information of the first row. Okay, we have to check if we will maintain two constant. Okay, we will loop through the first row. It will be value in the matrix 0. If value is 0, return true. Can we write it like this? Oh, it has a better written implementation that 0 is matrix. Wow. Okay, so first column has 0. Let's see if column has 0. Oh, there is any in Python. Let's see, what is it? Python any. Oh, it kind of, oh, it is cool. Like you can do a one-line code. Yeah, so it is Amy. So for how do you loop through the column? I in range row in matrix. Row 0 is 0. Okay, so back to the covering thing. If matrix I0 is if okay, so if at your row, if your column has 0, then cover it, and if your row has 0, cover it to 0 as well. So okay. Then after finish the coloring, let's deal with the first row. So if first column has 0, then we will color if how about if we didn't cover the 0 of the first column, like if okay, so if the first column has 0, did we already cover its row to 0? I don't think so. Let's check here. Oh, because yeah, we have already done it because yeah, it says if the first row has a 0, then it is already a 0 in the original. Then we will have already covered its column to 0, because the condition here. Okay, so we only have to color its own column or on the first column and the first row. So if first column has 0, then color it. And if the first row has 0, then color every column in the first row to 0. Oh no, why is it? Mm-hmm. Why is it? Why 0? This is the first row that has 0. Column any for every row in the matrix if the first column is 0. Yeah, and started from 1. If matrix ij is 0, then we will keep track of its column and its row to 0. Yeah. Then we will look through matrix again and color every grid, color every square. I mean like matrix ij if its row or its column is 0. Okay, I will draw like a diagram. So we'll first check if the first row has 0, it's false. Column has 0, it's false. For ij, started from 1. If matrix ij is 0, color its first row to 0, yeah, and its column to 0, yeah. And for okay, so that's move on to the matrix 1 and 2. No, it's not 0, and 2 1 is not 0 as well. 2 2 is not 0 as well. So then we will see okay, so we'll move on to the second for loop. So if matrix ij I0, okay, so if the first column is 0, okay, so we started from matrix 1 1, so 1 0, is it 0? The one row 0, yes, it is 0, so color it to 0. Okay, okay, next let's move on to 1 2. Is 1 0? Yes, it is 0, so color it to 0. Why it is not colored? Let's print it and check. Okay, so why it is not modified? Oh. Okay, got you. Oh, I'm thinking that because I'm using a DFS, so yeah, it is kind of slow because, and also the memory is counted like it default has an n stack size, so yeah, it is definitely slower compared to for loops. Yeah, okay, so then we will finish this problem.